Hey, hello there. So today's the binary search question that I picked is the 34, find first and last position of element in sorted array. The question is just as follows. We have a sorted integer arrays and we want to find the starting and ending position of a given target value. The algorithm has to be in log n times, so we apply binary search twice. The first time to find the first position for the element, the second time to find the last position of the element. Yeah, so that's pretty much how to solve this in log n time using binary search twice. And yeah, 2 days ago I was doing a little bit of review. So in my documents I have the template for search leftmost and search rightmost. I think the code has to be modified a little bit from my last time. The upper bound for both, I originally set this to be the size of the array subtracted by 1, points to the very last location. That will actually cause problems. After some analysis and very fun debugging when I try to just copy and pasting those two pieces of code here and keep saying arrow, I find that I should actually increase the upper bound to be the full size of the array. So yeah, just as a reinforce of memory, I should try this one more time with another language, I guess. So we're gonna have two methods. One is called binary search left, which is gonna take a reference to this vector and a integer target. What this does is to apply binary search to find the leftmost occurrence position for this target value. So initially the lower bound is 0, the upper bound is the array size. It's not the array size subtracted by 1. So the condition is the same thing. We are checking that if we are searching for the left, we want the leftmost. So what we want is that the middle element we are looking at is strictly less than the target. So that when we keep searching, the value that we find is going to be the first one that's actually equal to or larger than the target value. So return L. That's pretty much the binary search left. The binary search right, it's almost identical, except that we change this condition to be less than or equal to. So the left, when it's finally equal to the height, the search space pinned down to one number, that's gonna be the first number that's strictly larger than the target. So as a result, in this right code, we return left subtract by 1. So use these two subroutines to solve this problem. We're basically just gonna try to apply this on this array with the target value, and do that for the right as well. And then we pretty much just going to return the pal. There is one caveat to that we need to check the case where we have -1, -1. That's when actually the right is sorry. What's happening? Hope my code is saved. Okay, so that's when the it feels very tricky why that just happened. We want the right to be larger than or equal to L. If that's the case, then we can safely return this pal. Otherwise, it will be -1, -1. The case when we not be able to find the target, if that's the case, then L and right the left and right, the right is actually going to be smaller than L. You can look at the code and reason about that. And yeah, so pretty much that's just the code, the binary search left and right. The only difference is this equal sign and the return L-1 in the right version. With the left version is the strictly less than, so that we always want to bump L to be at least the target, at least equal to the target. It will be the first one that equal to the target. This one, L, will end up with the first one that's larger than target. So we return -1 to be the last one that equal to the target if it does exist. And here we just have a little condition checking here to make sure that we don't return something that's funny. You know, if it's the case we're likely to return funny, that's because the number is not in there. So we return -1, -1. Yeah, or there could potentially be another case is that the array just have one number. This will be catched in this condition checking here, and we return -1, -1 as a result. So I think this is the code. Yep. Okay. I should code this, right? No. Initializer list cannot used on right hand side operator. What's the problem? Can I just do this? Yeah, it works. So this is the binary search code to solve this question. One to the left, one to the right.